we need to find the divergence and the curl of the function 3x z I minus xy squared j minus 2x squared y k. Okay, so what we have here, this function a will be a function of a vector field. We need to find the divergence of a. Now remember, the divergence of a is really the dot product of the gradient vector and a, while the curl of a is a cross product of the gradient vector and a, where the gradient vector is a partial derivative of something by partial x in the I direction plus partial derivative of something by partial y in the j direction plus partial derivative of something by partial z in the k direction. Now, when you dot that with a, what you're going to get is this. Oh, by the way, let's not, I'm not going to do it yet. Pause the video and write down the question and try it. Okay, have you finished? Let's see what you get. Here now, you have grad dot, not cross, dot a, right, is, I'm just going to write it out fully here. You wouldn't need to write out all of this in exam in terms of writing this and in bracket and that and the other one in bracket, right? It would be good if you do though. This is the grad dot a 3xzi minus x y squared j minus 2x squared y k. Now remember, when you find the dot product of two vectors, you're going to get a scalar. It will not involve the directions I, j and k, just magnitude. So it's this times this plus this times this, whatever I multiply the j plus this time the k plus, which is what time the k plus this, that is what time the other k. Alright? So that's what you're going to do. Now, therefore you have partial by partial x, which is this, of this 3xz, alright, plus this one partial by partial y of this. Remember the negative xy squared, alright, plus partial by partial z, which is this, of this negative 2x squared y. Alright, so therefore when you differentiate this partial with respect to x, you get 3z. It's going to be a minus. When you differentiate this with partial with respect to y, you have 2xy, going to be a minus again. When you differentiate this with respect to z, you get 0 because there's no z there. So what you have here is that the divergence of a is equal to 3z minus 2xy. So you have that. Now the next thing in part 2 is the curl of a. So curl of a is the cross product between grad of A, between the grad, times A. That will give you, in this case, the gradient of A. When you found this is the dot product of grad. This is the dot product between the grad and A, right? So this is grad dot A. So we're going to find the grad cross A now. Now how do you deal with this? You're going to have delta by delta x in the I direction plus delta by delta y in the j direction plus delta by delta z in the k direction. Cross A. What is A again? 3xzi. So A is 3xzi plus, minus then, minus xy squared j, xy squared j, minus 2x squared y, k, minus 2x squared y, k. Alright? Now, when you find the cross product of two vectors, remember what you do. You're going to have a 3 by 3 matrix, a third order determinant, alright? Square matrix. Row 1 will contain the directions I, j, k. So, directions I, j, and k. Now, row 2 will contain coefficients of the first vector, the one on the left. The coefficients of I, of the direction in the first vector. That's what I should say. Let me just make an adjustment. Coefficient of I, j, and k in the first vector. We're reading from left to right, right? So the one on the left would be the first. So the coefficient of I, what is it multiply I here? It is delta by delta x. What is it that multiply j here? It's delta by delta y. What is it that multiplies k here? It is delta by delta z. Okay. And then in row 3 we have coefficients of I, j, and k in the second vector. That will be 3xz. So it's 3xz. Then here, negative xy squared. Because this is like plus negative xy squared, right? And I could have written it that way. There's negative xy squared, negative xy squared, then negative 2x squared y, negative 2x squared y. Alright, so you have that. Now,
what? Did you ever saw that building before?
Therefore, nabla cross A. No, the upside down triangle here with the point in the ground. That's nabla. Alright? Now, remember how you find the determinant of a 3 by 3 matrix. You have to remember these things, you know. Let me get I want a, let me get this rectangle here. I'm going to be using it as a line or something, right?
Spider!
it again here.
Yeah.
Let me turn it around. How do I turn this thing, man? I want this thing to turn. Oh, good, good. Okay, so remember now, it's going to be I times, then you're going to cover up the rows and column that contain I. Right? I wanted this thing to be longer. Oh, alright. I think this might have to be longer down to, you know. Oh, this was accidentally copied there. I times, and then we did have the determinant of what you can see. Delta by delta y, delta by delta z, negative x y squared, negative 2x squared y. Alright, you see that? Minus j now. So here, we're going to cover up the rows and column with j. Alright. And then the uncovered elements will form a determinant. So delta by delta x, delta by delta z, and you have 3xz, negative 2x squared y, plus k now. K, and you cover rows and column here. You have delta by delta x, delta by delta y, 3xz, negative x y squared. Okay, good. So you're going to find the determinant here now. So this is I time. Remember, when you have the 2 by 2 matrix A, B, C, D, the determinant is AD minus BC. So it's this way minus this way. Alright? That's how you multiply them. So this is going to be delta by delta y of negative 2x squared y minus this way now, delta by delta z of negative x y squared. Okay, minus j times, let me just erase what this is, minus j times this way, as delta by delta x of negative 2x squared y minus this way, delta by delta z of 3xz. Okay, plus k now. You multiply across this way. So this is delta by delta x of negative xy squared minus this way now, delta by delta y of 3xz. Okay, so there you have that. Now, what you have is I times, when you differentiate this with respect to y, you get negative 2x squared. Okay? Minus, well, it's going to be a minus negative. Oh. So here, if you have minus negative, you get a plus here. But guess what happened now? There's no z here. And since you're differentiating with respect to z, then you consider x and y constant, so it's 0. Alright? Minus j times the differentiate this with respect to x, you get negative 2x. Oh, no, not negative 2x. 2 times 2, negative 4x y. But you differentiate it. Minus differentiate with respect to get z you get 2 3x. Alright? So ensure you're following. Then out here you say plus k times, when you differentiate it with respect to x, you get negative y squared, and then minus differentiate it with respect to y, you get 0 because there's no y there. Now what happens here? This is equal to negative 2x squared I. Alright? If you multiply inside by negative 1, both will become positive. You'll see that this is going to be plus 4xy minus, no, plus 3x j. Alright? And then minus, it would be minus y squared k. Alright, so what you have there is the curl of this function a. So we did the divergence and the curl of the function. I'll see you in the next video then.